Hello everybody. In today's video, we'll be discussing a point called as circuit breaker. So in the previous video, we have been discussing what is meant by switch, what is meant by fuse, and its classification, etc. has been discussed in the previous video. In the continuation of the previous video, we'll be discussing circuit breaker in this video. As I have already told you that fuse is a basic version of a circuit breaker, and circuit breaker is an advanced version what a switch does. So there is a connection between, or else the working principle on which both these work will be the same, that is to protect our load from over voltage. Circuit breaker will be working very much similar to that of fuse. So in this video we'll try to learn what is meant by circuit breaker and what are the different types of circuit breakers that are available with us will be discussed in this video, and I'll be showing some pictures regarding circuit breakers in a video, so that easy identification of circuit breakers will be done when you encounter any kind of circuit breaker anywhere. Okay, so let's start our video first knowing what is meant by circuit breaker. So an electrical circuit breaker is a switching device which can be operated either manually or automatically for controlling and protecting an electrical power system. Okay, so the main purpose of an circuit breaker is nothing but to protect the load or protect any power system. Okay, as a modern power systems deal with huge currents, special attention should be given during designing of a circuit breaker to ensure it is able to safely interrupt the arc produced during the closing of a circuit breaker. This is a basic definition for circuit breaker, that is, a circuit breaker should be designed such that it should be able to safely interrupt the arc produced during the circuit breaker. Okay, so the modern power systems, as it is dealing with huge power networks and huge number of associated electrical equipment, during any short circuit or any fault or any other electrical fault such as electrical cable fault occurs, a high fault current will flow through this equipment as well as the power network itself. Okay, this high current may damage the equipment and the networks permanently. So for saving these pieces of equipment, that is our loads and the power networks, the fault current should be cleared from the system as quickly as possible. Again, after the fault is removed, the system must come into its normal working condition as soon as possible for supplying reliable quality power to the receiving ends. Okay, so not only uh, protecting the equipment from the faulty conditions, again it should recover itself such that it should work into normal working condition. Okay, so in addition to that, for a proper controlling of the power system, different switching operations are required to be performed. Okay, so this point we don't see in fuse, that is, when a fuse does a single action, that is, it protects from the overload and overcurrent by destroying itself, then we'll be replacing with a new fuse. Okay, whereas when we deal with circuit breakers, the purpose or the aim of the circuit breaker is that it should protect the equipment from the faulty conditions and after that it should again come into normal working condition, so that again the normal action between the load and the supply takes place. That is, it should disconnect itself when it detects any faulty condition, and after the problem has been resolved, again it should act in a normal way, act normally as it was working previously. That is, here the replacement which we see in case of a fuse will not be seen here in case of a circuit breaker. That is, when a circuit breaker comes into action, it will work, and again come back to its life, and it again starts working. Whereas in the fuse we don't see this kind of thing. Like, once a fuse is blown out, we have to replace it with a new one, or a wiring again should be done to the fuse. In case of circuit breakers, we don't see such kind of thing. Okay, so for timely disconnecting and reconnecting different parts of the power system network for protecting and control, there must be some special type of switching device which can be operated safely under huge carrying current. During the interruption of large current, there would be large arcing in between switching contacts. Okay, so the point to be noted here is that circuit breakers are dealing with large current. So when dealing with large currents and interruption of this large current, there will be a large arcing in between the switching contacts. So care should be taken to quench these arcs in the circuit breaker in a safe manner. Okay, handling of this condition while interrupting heavy currents should be done in a very safe manner. Okay, the circuit breaker is a special device which does all the required switching operation during current carrying condition. This was the okay, so this is what a circuit breaker has to do. Circuit breaker is handling huge amounts of currents. So while handling these huge amounts of currents, the arcing which occurs in between the contacts should be handled very safely, so that the contacts doesn't break out, or it does not it works safely when we again reconnect it, or again we restart its operation. Okay, so these are the points which are the basics for circuit breakers, and that are to be remembered. That is, a circuit breaker is a simple switching device. Either it can be operated manually or automatically, and it is nothing but a protecting device which is very much similar to that of a fuse. But the thing, or the difference between a fuse and a circuit breaker is, circuit breaker will be handling very huge amounts of currents when compared with fuses. Okay, so fuses are limited to a lesser amount of currents when compared with the circuit breakers. And the major difference between a fuse and the circuit breaker is, when a circuit breaker fuse does a single action. That is, when it detects an overcurrent, it burns itself in order to protect the load. Whereas circuit breakers will do this action, and in addition to this, it again comes into its normal condition after the overloading condition has been, or overcurrent condition has been settled down. Okay, so here the replacement or rewiring which we see in case of fuse, we don't see in case of circuit breakers. Okay, and other point is that we are dealing with huge currents with respect to circuit breakers. So while dealing with the circuit breaker, the huge amounts of currents are there. So the switching action should be done very safely in order to avoid any damage to the equipment or to the human. Okay, these are the points that we have to keep it in mind regarding circuit breakers. Now we'll see the working of a circuit breaker. Okay, the circuit breaker essentially consists of two parts, two contacts, or simply we can say it as two contacts. First one is fixed contact and the second one is moving contacts. Fixed contacts and moving contacts. So in this diagram you can see there is a container like thing. So in that you can see fixed contact and mobile contacts. That is, these red colored dots, these red dots are nothing but fixed contacts, and the below one is the below dot is nothing but moving contacts. Okay, these contacts are touching each other and carrying the current under normal condition when the circuit is closed. So when the circuit is closed, these just work like a switch action, that is, they help in passing the current through them. Okay, when the circuit breaker is closed, the current carrying contacts are called the electrode, engage each other under the pressure of the spring. Okay, so when the circuit breaker is closed, the current carrying contact, which now are called as electrodes, are engaged under the pressure of a spring. So there will be a spring action such that we see the current between the contacts and the circuit breaker is closed. During the normal operation condition, the arms of the circuit breaker can be either opened or closed for switching and maintenance of the system. To open a circuit breaker, just a pressure is required to be applied to a trigger. When a fault occurs on any part of the system, the trip coil of the breaker gets energized and the moving contacts are getting apart from each other by some mechanism, thus operating the circuit. Okay, so this is how a simple circuit breaker will work. Okay, that is, in normal on condition of the circuit breaker, the two contacts are physically connected to each other due to the applied mechanical pressure on the moving contacts. Okay, so what I am trying to say is, circuit breakers, we are seeing two different contacts. One is fixed contacts, other one is moving contacts. Okay, in normal on condition of the circuit breaker, that is, when the circuit breaker is in on condition, the two contacts are physically connected to each other, and they come in contact because of the physical pressure that we apply externally, like just we like any pressure which we apply for a switch, likewise we apply for the circuit breaker, the applied pressure between the contacts make the circuit breaker come into on condition. There is an arrangement stored in the potential energy in the operating mechanism of the circuit breaker, which is released if the switching signal is given to the breaker. The potential energy can be stored in the circuit breaker by different ways, like by deforming the metal spring, by compressed air, or by any hydraulic pressure. But whatever the source of potential energy, it must be released during the operation. The release of potential energy makes the sliding of the moving contact in a speedy manner. Okay, all the circuit breakers have operating coils. Whenever these coils are energized by switching pulse and the plunger inside them is displaced, this operating plunger is typically attached to the operating mechanism of the circuit breaker. As a result, the mechanically stored potential energy in the breaker mechanism is released in the form of kinetic energy, which makes a moving contact to move, as these moving contacts mechanically attached through a gear level arrangement with the operating mechanism. Okay, after the cycle of operation of circuit breaker, the total stored energy is released, and hence The potential energy again stored in the operating mechanism of the circuit breaker using spring charging motion or air compressor or by any other means. Okay. This is how a circuit breaker working principle looks like. That is by simple physical or mechanical pressure that is applied between the contacts, this circuit breaker will be working. So coming to the principle of the circuit breaker has to carry large rated or faulty power. Due to this large power, there is always dangerously high arcing between the moving contacts and fixed contact during the operation of the circuit breaker. Okay, so this point should be kept in mind while dealing with the circuit breaker, right? So and another point is that these circuit breakers will perform their function independently and without any supervision. There are also some remote control circuit breakers which can be operated on demand at a distance. Okay, so though we discuss all these things like we apply a pressure, then we release it, and all the things, these are the idealistic working principle. But in actual case, all these things like switching on, off, and again turning on, all will be done automatically, and the circuit breaker will function independently without any supervision. Okay, so these are the points regarding circuit breakers. And next we'll see what is the classification that is given to circuit breakers. So as it is displayed on the screen, you can see circuit breakers. There are four different types of classifications that we see for circuit breakers. The first type of classification is depending upon the voltage. So we can classify circuit breakers firstly based on the voltage. Based on the voltage, we will be having two different types. And again, another classification of circuit breaker is by installation location. Next is based on the external design. Again, we have different types of circuit breakers. And by interrupting mechanism, also we have several other different types of circuit breakers are available. All these four different categories of circuit breakers will be discussed in this video. Okay, so let's see one by one. Okay, now we'll start or see what is the classification of the circuit breaker based on voltage. So in this category, we see two different types of voltage circuit breakers. The first one is low voltage circuit breaker. Second is high voltage circuit breaker. So low voltage circuit breakers are nothing but these breakers are rated for use at lower voltages up to 2 kilovolts. So 2K, that is 2000 volts, up to 2000 volts, these kind of circuit breakers can be used and are mainly used in small scale industries. Okay, next is high voltage circuit breakers. So which is contrast to low voltage one, that is this can be used for a voltages which is greater than 2 kilovolts. So more than, if you want to operate a circuit breaker below up to 2 kilovolts, it is called as low voltage circuit breaker. Or more than 2 kilovolts, the circuit breaker that we have to use is high voltage circuit breaker. Again, these circuit breakers are subdivided into transmission class breakers, that is those which are rated 123 kV and above, and medium voltage class, that is lesser than 72 kV circuit breakers. Okay, high voltage circuit breakers again uh, classified into two, like transmission class breakers, that is which are rated at 123 kV and above, and medium voltage class circuit breakers which are nothing but which are lesser than 72 kV, that is more than 2 kV to 72 kV medium voltage class we call it. Okay, so this is the classification regarding circuit breakers based on voltage. Low voltage circuit breakers used up to 2 kilovolts, and high voltage circuit breakers which are used above 2 kilovolts range. Okay, now we'll see the other type of classification, that is based on the installation location. So all the times the circuit breakers may not be placed inside an equipment or inside an industry or so. They may be placed indoor or outdoor. So based on the installation, these circuit breakers can be of two categories, categorized in two ways. The first one is indoor circuit breakers, second one is outdoor circuit breakers. So from the name itself we can get to know where these kind of circuit breakers can be used. Okay, so indoor means indoor. These are designed to use inside our buildings or in weather resistance enclosures. So where environmental conditions have to be kept in mind and the protection of circuit breakers has to be done, then indoor circuit breakers can be used, and these are mainly used inside the buildings. These are, as we are using inside the buildings where humans reside, so generally these kind of circuit breakers operate at medium voltage with metal clad switch gear enclosure. So the rating will be of medium voltage rating and will be having a metal clad switch gear enclosure. And the next one is outdoor circuit breaker. So you can use these breakers outdoor without any roof due to the design. So when compared with indoor, outdoor circuit breakers will have robust construction, as they will be using externally, like they will be working any uncertain environmental conditions. So these kind of circuit breakers, that is outdoor circuit breakers, will be robust in construction when compared with indoor circuit breakers. Their external enclosure arrangement is strong compared to the indoor circuit breaker, and they are designed in such a way that they can withstand wear and tear. Okay, so these can be of any kind, like it can be a low voltage circuit breaker or high voltage circuit breaker, but the thing is that they will be installed outside, and installation has been done outside, so they will be very strong when compared with the indoor circuit breakers. Okay, this is how we classify a circuit breaker based on the installation uh, location. Okay, next we'll see another classification, that is based on the external design. So based on the external design, we have two types. First one is dead tank circuit breaker. The second one is live tank circuit breaker. Tank circuit breaker, we'll see what is dead tank circuit breaker. These circuit breakers whose enclosed tank is at the ground potential is known as dead tank circuit breaker. That is, the tank is at ground potential is known as dead tank circuit breaker. The tank enclosures all the insulating and interrupting medium. That is, in another words, we can say that the tank is shorted to ground or is at dead potential. Okay, either grounding, we say it as either grounding, or it is at zero or dead potential. Okay, this is dead tank circuit breaker. Next one is live tank circuit breakers. These breakers have a tank housing interrupter. that is at a potential above the ground. This is above the ground with some insulation medium in between them. Okay, which does not which will be placed at zero potential or shorted ground. We call it as dead tank. Whereas there will be certain amount of potential at the ground level, or it is above the ground with some insulation between them, then we call it as live tank circuit breaker. Okay, so these are the two different types based on the external design. Okay, next one is by interrupting mechanism. In this category, we see many kinds of circuit breakers, that is almost around up to 9 different types of circuit breakers are available in the interrupting mechanism. So let's see one by one. First one is air circuit breaker. This breaker uses air as an insulating and interrupting medium. Okay, so this breaker is again subclassified into two types based on its voltage operating range. First one is low voltage circuit breaker, whose value lies between 1000 volts. Second one is high voltage circuit breaker, whose value is 1000 volts and above. It is further classified into oil circuit breakers and oil-less circuit breakers. Okay, so in general, 8 circuit breakers are nothing but which uses air as insulation and interrupting medium. Based on the voltages, again we have low voltage and high voltage air circuit breakers. In contrast to this, instead of using air, if we use oil as interrupting and insulating medium, then we call it as oil circuit breaker. So oil circuit breaker is nothing but it is a circuit breaker which uses oil as an interrupting and insulating medium, and these breakers are again divided into two types based on the pressure and amount of oil used. That is vacuum circuit breakers. These breakers use vacuum as their interrupting medium due to its high dielectric and diffusive properties. Okay, the next one is M.C.B. This term we might have heard in our houses most frequently. Before these MCBs, we used to call it as fuse, but these days in every house MCBs are in common. Okay, the full form of MCB is nothing but miniature circuit breaker. The current ratings of this breaker are less than 100 amperes and has only 1 over current circuit protection which is built inside it. The trip settings are not adjustable in this circuit. Okay. Next one is MCCB. That is nothing but molded case circuit breakers. The current ratings of these breakers are higher than 1000 amperes. They'll have earth fault protection along with the current protection. The trip settings of the molded case circuit breakers can be adjusted easily, like what we see in MCBs. In contrast to that, adjustments can be done, that is trip setting adjustments can be done in MCCBs. Next one is single pole circuit breaker. This is a circuit breaker which has one hot wire and one neutral wire, and that wire which operates at 120 volts. When there is a fault, it will interrupt just the hot wire. So it will be made up of two wires. So when a faulty condition will occur, one wire will get interrupted. So that kind of circuit breaker is nothing but single pole circuit breaker. It is used to operate at 120 volts. Next one is double pole circuit breaker. This kind of circuit breaker is generally used at 220 volts. These are there will be two hot wires and both the poles need to be interrupted. So when a faulty condition occurs, both the poles which has to be interrupted in case of double pole circuit breakers. Next one is GFCI circuit breaker. Ground fault circuit interrupted. GFCI means ground fault circuit interrupter. Okay, these are safety switches that trip on ground fault currents. The GFCI breaker interrupts the electrical circuit when it detects the slightest variation between the phase and the neutral wires. So if any small variation between the phase and the neutral wire is detected, in the electrical interruption will be made with this GFCI circuit breakers. And the last category of circuit breaker is nothing but arc fault circuit interrupter, AFCI. Okay, the AFCI circuit breaker interrupts the circuit during excessive arc conditions and it prevents fire. Okay, under the normal arcing position, this breaker will be idle and it will not interrupt the circuit. Okay, so this kind of circuit breaker, AFCI circuit breaker, is mainly used mainly only to interrupt the circuit when excessive arc conditions occur, and in order to prevent fire condition, these kind of circuit breakers are used. So these are the different types of circuit breakers which are defined and classified based on the interrupting mechanism. Okay, so till now we have been discussing the different types of circuit breakers. First is based on voltage, next based on installation location, next is external design, and on the interrupting mechanism. Various kinds of circuit breakers have been discussed. And now let's see some kind of different types of circuit breakers that are available in the market and its external view I'll try to show, so that when you come across these kind of circuit breakers, you'll just identify these things. Okay, let's see breakers.
Breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit or in no load condition. Circuit breakers are made in varying sizes, from small devices that protect low current circuits or individual household appliances up to large switchgear designed to protect high voltage circuits feeding an entire city. The generic function of a circuit breaker, RCD, or a fuse as an automatic means of removing power from a faulty system is often abbreviated as OCPD. Many classifications of circuit breakers can be made based on their features such as voltage class, construction type, interrupting type, and structural features. In this video, I will going to show you different types of circuit breakers. Firstly, we classify the circuit breakers according to the voltage level they can operate on. So there are three most used types of circuit breakers in this category. 1. Low voltage circuit breaker. 2. Medium voltage circuit breaker. 3. High voltage circuit breaker. Low voltage circuit breaker. Low voltage circuit breaker types are common in domestic, commercial, and industrial application and include MCB, miniature circuit, rated current not more than 100 amp, trip characteristics normally not adjustable, Thermal or thermal magnetic operation breakers illustrated above are in this category. MCCB molded case circuit breaker rated current up to 2500 amp thermal or thermal magnetic operation. Trip current may be adjustable in larger ratings. Low voltage power circuit breakers can be mounted in multi-tiers in low voltage switchboards or switchgear cabinet. Medium voltage circuit breaker. Medium voltage circuit breakers rated between 1 and 72 kV may be assembled into metal enclosed switchgear line up to for indoor use, or maybe individual components installed outdoors in a substation. Air brake circuit breakers replaced oil-filled units for indoor applications, but are now themselves being replaced by vacuum circuit breakers up to about 40.5 kV. High voltage circuit breaker. Electrical power transmission networks are protected and controlled by high voltage breakers. The definition of high voltage varies in power transmission work is usually thought to be 72.5 kV or higher. High voltage breakers are nearly always solenoid operated with current sensing protective relays operated through current transformers. In substation, the protective relay scheme can be complex, protecting equipment and buses from various types of overload or ground or earth fault. High voltage breakers are broadly classified by the medium used to extinguish the arc. There are four types in this category. 1. Air circuit breaker. 2. Oil circuit breaker. 3. SF6 circuit breaker. 4. Vacuum circuit breaker. Air circuit breaker. Air circuit breaker is an electrical device used to provide overcurrent and short circuit protection for electric circuits over 800 amps to 10k amps. These are usually used in low voltage applications below 450 V. Airbag circuit breaker, the arc is initiated and extinguished in substantially static air in which the arc moves. Oil circuit breaker. Oil circuit breaker is such type of circuit breaker which used oil as a dielectric or insulating medium for arc extinction. In oil circuit breaker, the contacts of the breaker are made to separate within a insulating oil. SF6 circuit breaker. A circuit breaker in which SF6 under pressure gas is used to extinguish the arc is called SF6 circuit breaker. SF6 gas has excellent dielectric, arc quenching, chemical and other physical properties which have proved its superiority over other arc quenching mediums such as oil or air. Vacuum circuit breaker. A vacuum circuit breaker is a kind of circuit breaker where the arc quenching takes place in vacuum medium. The operation of switching on and closing the current carrying contacts and interrelated arc interruption takes place in a vacuum chamber in the breaker, which is called vacuum interrupter.
So with this, we got to know the different types of circuit breakers that are commonly available with us. So in the video that I have uh, presented right now, we have seen the various categories of circuit breakers, and their different diagrams have been shown to you for a clear understanding, and also its ratings and the ranges at which these currents and voltages can be operated is also mentioned there. Okay, so with this, I expect that you people got to know what are the different types of circuit breakers, and initially you got to know what is meant by a circuit breaker and its working principle, classification, and what are the different kinds of circuit breaker that are available with in the market have been identified and shown to you with the help of a video. So with this, we'll stop the session for today, and in the next coming videos we'll discuss other points in extension to the circuit breakers. Okay, thank you.